So we can continue with our revision. They want us to look at how to find the multiplicative inverses in modular arithmetic. Now, there are several methods, but I will be using the extended Euclid's algorithm to find those inverses. I talked of multiplicative inverses because I know we have also additive inverses, but for additive inverses, it's easy to find. I'll just define what an additive inverse is, and then we can proceed from there. Then, after that definition, we go to multiplicative inverses. Now, what is an inverse, an additive inverse of R? An additive inverse of R, B, would be said to be an additive inverse of R if the sum of these two gives us 0. If the sum of these two gives us 0, and then we say that B is the inverse of R. For instance, if I'm talking of mod, the inverse of 3, the additive inverse of 3, mod 7, would be 4. Cos 3 plus 4, mod 7, gives me 0. Gives me 0. So when we talk about additive inverse, that is easy. Just looking at what element, when added to this element that I've been given, would give me 0. 0 is the identity element and addition. So if we talk of mod, let me talk of what is the additive inverse mod 10, additive inverse of 3. What is the additive inverse of 3 in Z10? So the additive inverse of 3 in Z10 of that element, which when added to 3 gives you 0 or gives you 10, and you know that 10 will be 0. Is that okay? So that element, the inverse of 3, will then be 7. Because we know that the sum of these two will give us 0 or 10. So and this is how we represent, this is how we write the inverse of 3. The inverse of 3 will be written as this, -3. If you are asked to find -3 mod 10, -3 mod 10 is the same as find the inverse of 3 mod 10. And we know what the answer is. The answer is 7. So that's how we write additive. The additive inverse of A will be denoted as -A. The additive inverse of 11 mod 20 will be 9. So that is how we do additive inverses. But what I want us to look at today is multiplicative inverses. And we do that by extended Euclid's algorithm, which we learned. So again, I just define what I mean by a multiplicative inverse. Just define again, the same way I've defined an additive inverse. So the multiplicative inverse of A, the inverse of A shall be denoted as this. That is multiplicative inverse. So for instance, the multiplicative inverse of M mod M, this is how we write it. And if B is that inverse, if B is the inverse of A, then it means that A times B is supposed to give us 1, mod M. If this happens, then we say that B is the inverse of A or A is the inverse of B. Is that okay? But under addition, we said the additive inverse will be that element which when you, the two elements, when you add them, gives you 0. So because 0 is the identity element under addition. Under multiplication, the identity element is 1. So my definition, I've written my definition and said that if B is a solution to the equation AX is 1 mod M, and you see what I'm saying is that if this X is B, if this X is B, such that A times B gives me 1 mod M, then B is the multiplicative inverse of A. That is what this definition means. That if this X is B, such that A times B here gives me 1, then B shall be the multiplicative inverse. Now, for us to find additive inverse, it's very easy. Every element would have an additive inverse. Every element would have an additive inverse. But not every element has a multiplicative inverse. Not, I say, under addition, every element would have an additive inverse. For instance, when you're talking about Z8, mod 8, if you're talking about mod 8, under addition, and we know what we mean by mod 8. What we mean by mod 8 here, we mean this is the set comprising of element 0, 1, 2, 3, 4, 5, 6, 7. So what I'm saying is, under addition, each of these elements have inverses under addition. Because the inverse of 1 is 7. Is that okay? The inverse of 1 is 7. The element which when I add it to 1, I get 0, mod 8. In other words, and what do I add to 1 to get 8? That's what I mean. And 8 will be 0. So the inverse of 2 under addition will be 6. The inverse of 3 under addition will be 5. The inverse of 4 under addition will be 4. Is that okay? Under addition, the inverse of 5 will be 3. Under addition, the inverse of 6 will be 2. And under addition, the inverse of 7 will be 1. The inverse of 0 is 0. So each of these elements under addition have inverses. But under multiplication, the only elements which would have inverses are those which are relatively prime to 8. Elements which are relatively prime to 8. What I mean by relatively prime is that coprime, elements which are coprime. What I mean by that is that an element n would have an inverse if n and 8, the GCD of these two, if the GCD of these two is 1. That's what I mean by relatively prime. So when I say that n is relatively prime to 8, I mean that the GCD of n and 8 is 1. The other word that I could use is that the only common factor between n and 8 is 1. Is that okay? The only common factor between n and 8 is 1. So what I'm saying is, under multiplication, the only elements which will have inverses here are those which, when you combine with the 8, the only common factor will be 1. Is that okay? So we can know which elements will have inverses. For instance, 3 would have a multiplicative inverse. Is that okay? 5 would have a multiplicative inverse. And 7 would have a multiplicative inverse. These are, and even 1. And even 1. These are the elements which are relatively prime to 8. Those are the only ones that have inverses here. Multiplicative inverses. Is that okay? Yes. So these are the only ones that have multiplicative inverses. But in addition, we said all of them will have inverses. Is that okay? Good. Now, so which elements would have inverses here? Z10. We're looking at mod 10. Which elements will have inverses? Let's begin with 1. Which other element will have an inverse? 3 would have an inverse, multiplicative inverse. 7 would have a multiplicative inverse. 9 would have a multiplicative inverse. And have you seen how many elements there are? There are 4. There are 4, and this is what we call phi of n. This is what is called phi of n. Euler phi of n. Euler phi of n, we said, Euler phi of n are elements less than n, greater than 0, but less than n, which are relatively prime to n. Elements which are relatively prime to n. Is that okay? Smaller than n, but relatively prime to n. So Euler phi of n tells us how many elements have multiplicative inverses. We saw how to calculate Euler phi of n. If n is a prime number, if n is a prime number, we say Euler phi of n be given by that prime number minus 1. Is that okay? If it's not prime, we said now we come up with prime factors. Come up with the prime factors. Like, for instance, 10 has 2 and 5 as the only prime factors that can divide it. The only prime factors that can divide 10 are 2 and 5. So to get how many elements are relatively prime to 10, how we did it earlier was that a half times 4 to 5 times 10. And that gives you 4. There are 4 elements relatively prime. So it's good to know how many elements would have inverses. Is that okay? How many would have inverses under mod 10, mod 20, mod 1,000? And we are saying that those are elements which are relatively prime. You can use Euler phi. Now, but what I wanted is just to now find the inverses. Find those, but it's good to know so that if you are told to find the inverse of 6 mod 8, you know that it does not exist. 6 mod 8, 6 will not have an inverse. So somebody cannot ask you that to find the inverse of 6 multiplicative inverse. If it's additive inverse, we can get, because it will be 2. But the multiplicative inverse, 6 mod 8 is not there. Now, so I want us to begin with what we've just talked about. We've talked about inverses mod 8. Inverses mod 8. I want us to find the inverse of 5. I want us to find the inverse of 5 mod 8. The inverse of 5 mod 8. How we normally do it? We know that 5 would have an inverse. Is that okay? 5 would have an inverse. How we normally do it? We use the extended Euclid's algorithm. So we begin by Euclid's algorithm. We ask ourselves, 5 into 8, how many times? And what is the remainder? Now the remainder is 3. What about 3 into 5? 3 into 5. It will go there once. And the remainder will be 2. What about 2 into 3? Go there once. And the remainder will be 1. And you know that this one is the GCD. Now, so after that, we now use the extended Euclid's algorithm to now find the inverse of 5. We begin by reversing. Like this one, the subject. So 1 would be the same as 3 minus 1 followed by 2, which is 3 minus, we now replace this 2 replace these two here. Its equivalent is 5 minus 1 multiplied by 3. This is the same as 3 minus 1 multiplied by 5 plus 1 multiplied by 3. And this is the same as negative 1 multiplied by 5 plus 2 multiplied by 3. Now replace 3. Replacing only the remainders. So this will be the same as negative 1 multiplied by 5 plus 2 multiplied by 3, but 3 is 8 minus 1 multiplied by 5. 1 multiplied by 5. So this will be negative 1 multiplied by 5 plus 2 multiplied by 8 minus 2 multiplied by 5. Is that okay? Is that okay? You? This is 1 multiplied by 5. This one. It's this from here. Negative 1.5. It's this part. Huh? This is here. This is 1.5. Which one is that? This one, eh? This one. Huh? 1.3. 1.5. Then the 2 point. It's 2 times 3. Is that okay? Yes. You see, I have this 3 and I have this 1.3 and I'm factorizing. 3 plus 1 times 3. When you factorize 3 outside the bracket, what is inside the bracket? This 3 goes here 1 and also goes here 1. So this gives me 2. That is how I get the 2. Just factorized. You bring the common terms together. So when you bring those common terms, you see like this one, you see this one, this 3 here. Somebody can still write it as 1 times 3. Because it doesn't make any change. And I also have 1 times 3. So I'm just adding this. And 3 is a common term. So 3 is a common term. So when it divides here, you remain with the 1. And again here, remain with the 1. Get that 2. Now, so at this point, what we now get is 2 multiplied by 8 minus 3 multiplied by 5. We've arrived at the answer we wanted. We began to seek for the inverse of 5. We understand that the inverse of 5 is that element which, when multiplied by 5, gives you 1. Is that element which, when multiplied by 5, gives you 1. We found that that element is negative 3 mod 8, which is same as 5. Negative 3 mod 8 is same as 5. So in other words, the inverse of 5 is 5. What I mean is 5 times 5 is supposed to give me 1 or the 8. That's what I mean by 5 being the inverse of 5. That 5 times 5 is supposed to give me 1. Is it? Does it give us 1? 5 times 5? Mod 5, mod 8. It gives us 1. Is that okay? Now, so just the method we've used is the extended Euclid's algorithm. Of course, we have other methods, but I want us to know this first, so that when we look at RSA again and other applications, and we are getting inverses, we can use it also. We're supposed to know to get this inverse so that we apply them in RSA and those other crypto systems, getting inverses. When you are coming up with the keys, you're coming up with the private and public keys, inverses are very crucial. And let's look at this example. Let's find the inverse of 7 mod 19. The inverse of 7 mod 19. So of course we know that the 7 has an inverse because it's relatively prime to 19. It has an inverse. So it's that inverse that we want to obtain. So as we normally do, again, using the Euclid's algorithm, you ask yourself, how many times does 7 go into 19? And you'll find that it goes there 2 times, and the remainder is 5. Then what about 5 into 7? 5 will go into 7 once, and the remainder will be 2. What about 2 into 5? Go there twice, and the remainder will be 1. I obtained the GCD. Now you make this GCD the subject of the formula. Begin reversing as you go up. Now, let me write it above here. 1, which is our GCD, will be given by 5 minus 2 multiplied by 2. So you've already done away with the first remainder from the bottom. Now replace the second remainder from the bottom. Replace it by what? By this. That is equivalent. So this will be the same as 5 minus 2. This 2 is the one we are replacing by 7 minus 1 times 5. This gives us 5 minus 2 multiplied by 7, then plus 2 multiplied by 5. These two are like terms. This and this are like terms. Bring them together. Bring them together, and what do you get? Bring them together. This one, first of all, is 7. 2 times 7. And this is 3 times 5. When you bring them together, those are like terms when you factorize. We've replaced the second last remainder. We now replace the last remainder. This one, 5. So let's replace it. This will be negative 2 times 7 plus 3 into, instead of 5, we have 19 minus, my space is small here, but this is 2.7, 2 times 7. My space is quite small. That is 2 times 7. Now open the brackets and you get negative 2 times 7, 3 times 19, and negative 6 times 7. Is it? Or I can write it here. What I've written there is negative 2.7, 3 times 19, 6 times 7. I'm using those dots to mean times. So this gives us 3 times 19, negative 8 times 7. What we wanted to get was the inverse of 7, and it's that element which, when multiplied by 7, gives you 1. That element is negative 8 mod 19, which is same as 11. Is it the same as 11? Are we together? Okay. Want to look at 2 other examples, and then the floor is open to us for discussion. I want us to look at how the inverse of 11 mod 19. Do you agree that 11 mod 19 has an inverse? Because there we said they are relatively prime. Is that okay? Yes, since they are relatively prime, you can find the multiplicative inverse. If it were an additive inverse, what will be the answer? Additive inverse. What will be the additive inverse of, in fact, that one we write it this way. What is negative 19? In other words, what is the additive inverse of it? No, what is negative 11? The additive inverse of 11 is what? 8. Is that okay? So the additive inverse, it's easy to see. So we want multiplicative inverse. So when it comes to security issues, what you normally look at is you look at what is hard for people to break. Is that okay? Yes, so additive inverses will then be very easy. That is why they don't have a lot of applications. Yes.
Yeah. So what you say for additive inverse? Additive inverse is when you add it and
gives you 0.
It gives 0. So
yes.
Depends on what comes. 11 plus the value of.
Like when we talk of mod 19, the inverse of 11 would be that element added to 11 gives you 19. An element which, when added to 11, gives you 19. And you know 19 mod 19 is 0. Because 19 mod 19, you're asking yourselves, if 19 were to go here, what will be the remainder? So the remainder is 0. So that's why we are avoiding saying that it's that element when added to this gives you 19. We know that 19 is supposed to be 0. Is that okay? But in short, what we're just saying, the inverse of 8 mod 19 will be that element which, when added to this, added to 8, gives you 19. The inverse of 7 with that element which, when added to 7, gives you 19, which is 12. Is that okay? No, we will not ignore the negative sign. It is the negative sign that we are using to tell that the question wants the inverse. Yes. The negative sign telling us that that is the inverse. Just the same way, this one, when you see this, when you see this, you're able to tell that this is an inverse of 3. Is that okay? Under multiplication, this is how we write the inverse of 3. Under addition, this is the inverse of 3. Yes, under addition. And under addition, how do we get the inverse of 3? We are saying, what is the element which, when added to 3, gives you 0? Is that okay? Added to 3. No, mod 19.
Mod 19.
Yes.
What gives you 19?
Yeah. Yes, mod 19. You're asking yourselves, we are asked to find -3 mod 19. Find mod 3 -19. The way we were doing last time you were here, we said we will take -3. Let me give you this example. Then divide by that. The remainder will be what? And I said, you see, if you ignore the minus, the explanation I said, ignore the minus. When you ignore the minus, then 19 go there 0 point something. Then take the next whole number. Instead of 0, the next whole number will be 1. And give it a minus. So when you multiply that, you get -19. When you subtract here. So the additive inverse of -3 is 16. It is that element which, you see, just this minus, take it as a command to get the inverse. Just a command, is that okay? Just a command. So just telling you, find the inverse of 3. While calculating the inverse of 3, ignore the command. Let the command just give you the direction of what you're supposed to do. So the command is telling you find the inverse of 3. And then what is the inverse of 3? It's that element which, when added to 3, gives you, when you talk about mod 19, it should give you mod 19. It should give you 19, but 19, of course, is 0. Is that okay? So that element, therefore, is 16. That is the inverse of 3. It's clear? Is it clear? Is that okay?
Yes.
What is the inverse of 16 mod 20? 16 mod 20. Additive inverse. Additive inverse. So you just ask me, what element, when added to 16, gives you 20? That's the question. And the answer is 4. Is that okay? What is the inverse of 98 mod 100? Additive inverse of 98 mod 100? Additive. Should be 2. Is that okay? Is that okay? Like in Umaelewa.
Like they get mad. Like we using, like the thing is, like using mod and having so just doing something.
No, but it's just what I've said. What I've said is the inverse of when you are looking at addition, the inverse of 2, inverse. Let me now remove the word negative. Let me remove negative and just write inverse, additive inverse of 2 mod 5 is that element which when added to 2 gives you 5. That's what it does. So you just make it the subject of the formula. You get 3. Is it okay? What would be the inverse, additive inverse? What would be the additive inverse of 4 mod 9? Yes? 5. Yes. It's that element which when added to 4 gives you 9. Is that okay? Yes. And when you make it the subject of the formula, you find that element to be 5. That's what we talk about additive inverse. Yes. Now that is what we are doing. Like this example 2 is doing that. It's example 1 where we are using the Euclid's algorithm. See that one you use the Euclid's algorithm. Yes. So the other time you used Euclid's algorithm and you led us in one example. Yeah. Yes. It's just the same thing. Yes. Because I remember you led us in one example, and again today you are leading us in another one after this. Now, so let's find the inverse of 11. This is now multiplicative inverse. Is that okay? We use the Euclid's algorithm. Euclid's algorithm is where we are using these divisions, and every time you're noting the remainder. Is that okay? And then after that, use the extended. Extended is now when you make this GCD the subject and start replacing the remainders as you go up. That's the extended Euclid's algorithm. Now we begin by Euclid's. We ask ourselves, 11 into 19. Go there how many times? And the remainder of what? 8. Now 8 into 11. 8 into 11, 8 will go there once. And the remainder will be 3. Now 3 into 8 will go there twice. And the remainder will be 2. Now 2 into 3. Go there once. And the remainder will be 1. If you go on another step, the remainder will be 0. Is that okay? So this is our GCD. Make it the subject. So what we are now using from here, hence, is the extended Euclid's algorithm. Is that okay? This one was the Euclid's algorithm. Now we begin the extended Euclid's algorithm. Make 1 the subject of the formula. 3 minus 1 times 2. Replace, we've already replaced the first, this remainder, we've already replaced it by the equivalent. Now replace the next remainder by the equivalent. The next remainder is 2 and is here. So you replace it at this point. So this will be the same as 3 minus 1 multiplied by, instead of this 2, we write the equivalent, which is 8 minus 2 multiplied by 3. open the brackets. You have -1 outside. So you multiply by those elements inside the bracket. But before that, you have a 3 here. And when you open this bracket, you have 1 multiplied by 8. Then you have +2 multiplied by 3. Collect like terms. After multiplying, you realize that like terms. I can see 3 appearing twice. So those are like terms. So let me write it above here. This gives me -1 times 8. Write it here. -1 times 8 plus 3 multiplied by 3. 3 multiplied by 3. Which equals, we had replaced this remainder. Now the next remainder is 3 that we want to replace. This will give me -1 multiplied by 8 plus 3 multiplied by. Instead of that 3, we write the equivalent, which is 11 minus 1 times 8. So this gives me 3 times 11. And this will be -3 times 8. And there's a -1 times 8, which is then -4 times 8. Let me collect like terms. Now replace the last remainder, which is 8. Replace the last remainder, which is 8. Let's do it here. 3 times 11 minus 4, and it's 8 that we are writing the equivalent. 1 times 11. This is 11, 1 times 11. One times 11. Now let's open that bracket. I'll do it here. This will give us 3 times 11. This thing is at some point, some place it doesn't write. So let me just do it, get some space for it. Let me do it here. We are at this step, So this is 1. 1 is equals to -4. -4 times 19. -4 times 19. And then this is -1 times 11. But there's -4 outside. That gives us +4 times 11. +4 times 11. And there's a +3 here, which gives us +7 times 11. What we wanted was the inverse of 11. The element which when multiplied by 11 gives you 1. That element is 7. So the inverse of 11 is 7. Yes. I'm sure you are now ready to come and take us through the next exam. Come on, take us through. If you get stuck, the class will assist. I'm sure you will not get stuck. Let me create a smaller question for you. I want you to come and find the inverse of 9 mod 23. Come and give us that. The inverse of 9 mod 23. We agree that 9 would have an inverse. We agree that it will now give us.
So we're going to find the inverse. So first of all, what he said is you do the Euclid theorem first. You find like maybe the GCD from what I've understood. So you find maybe first is the Euclids. So that's step one. Step one is Euclids. So like question is -9 mod 23. Yeah, so like I think like you're supposed now to see like how many times can 9 go to into 23 or the other way around. You get. So I guess like you put 23 here, then is equals to this is how you do it. Then like 9 goes to 23, I guess like twice. So it's like 9 here, then like twice, then the remainder plus the remainder now. The remainder which is like 4. Oh, like 5. So you continue. Now you take the like this is like the 9 we use. So like you take the I think you take the 5 now. Like you take the 9 now, I guess. Divided by 5. Let me check. Yeah, I think take the 9 here. Then you divide by 5. So how many times does 5 go to 9 times? So here 5 goes there once, then multiply by 5, then plus the remainder which is like 4. You get. So basically we just take this one here, or from what I want to do, you just take it here, then you divide by the remainder, which is this one now. So it becomes here, it becomes 5, then you divide by 4. So basically 4 comes here. So 4 comes there, then it goes there like once, I guess. 1.4. Then the remainder, I think, is plus 1. I'm not so sure again. So take it to a grain of salt. So the remainder is like this. So this is like basically this is the GCD. Now we go now to reverse like I think it's reverse engineering it. You get. So now we start replacing the values from like we got here like 1. So like now we make like the GCD, which is this, into the subject of the formula. So it becomes 1, which is equals to 5 minus 1.4. You get. So what is said, now we do the inverse of the like replacing these values, the remainder values into like go like upwards. I'll show you as we go. So like we've done the first one, like you now need to replace 4 into this first equation. Yeah. So I'll do my like I guess like replace 4. So this 4 becomes 4 is equals to 9 minus 1 times 5. I guess. Yeah. So this value here that you get here is the one like you replace on the 4 here. The 4 here. So you can take, so it becomes 1 is equals to 5 minus 1 point. So you replace this whole thing. This is now the 4 now, the new 4. So it becomes into brackets now 9. Now 9 minus 1 times 5. Yeah. So after you finish that, you know, it becomes 5 minus. So 1 times 9, which is basically 1 times 9. So here, like there's 2 negative signs, so it becomes positive. So it becomes 1 times is it plus? I guess it's plus 1 times I'm not so sure. 1 times, I guess just like it's like I think like 1 times this one is like it gives you 2 now. You get, because like it gives you 1 times 1 is 1 times 5, like this. So I think I can do it up to there. So let me think. I think now we like supposed to collect like terms. I guess so. I guess yeah, is like 1 is 5. 5 minus 1 minus 4. So we take the plus 1, 1 to 4, replace 4, which you got 4 is 9 minus 1.5 plus 9, 5 minus 1.9 plus 1.5. So hebu msaidie kupita hapa nitafanya. Yeah. Like collect time. So I think like 1 times 9 is 1 times 9. So negative 1 times negative 1.5 is like we have 5. So this one. So it's like, so this one is basically 1 times 5. This is
1 times 5 plus 1 times 5.
Oh, so like you change this one to 1 times 5, like this 1.9 plus 1.5. So you collect like terms like this, which will become 2.5. 2.5, 1.9. Now you come here. You go. Now you replace this one, this 4 here. Like you replace the 4, done this one, done twice. Now you replace the 5 now, I guess. So let me just write it here. So it will become like replace 5, which is power 5, 23, minus this 23, minus 2.2 times 9, I guess. So like you replace this 5 into the new equation, I guess. So we found out like 5 is equal to 23 minus 2.9. So 5 is equal to 23 minus 2.9. So you come here into this equation. Now it starts with like 1.9, 5.9. Yeah, 5. So 1.9, then which this is equal to plus. Now 2, now replace the 5, which you now know is it is multiplication 23, which is I guess minus 2.9. 2.9. Like that. So after this, you write 1.9 plus 2 times 23, I guess it's 2 times 23. Then 2 times this one is like what will you get here? 2.9. So it's like 2 times 2.9. So I think it's like 2, I guess like plus it becomes like minus. So it becomes the negative sign. So if minus here, so it becomes like 4 times 9. You get. So after that, you collect like terms, which is like now negative 1.9 minus 4.9. I guess this is the same mathematical equation yeah, I guess so. So this one I guess is if I've done it correctly, it becomes 5. This one is like additional negative 5.9 plus 2 times 23. And we're looking for the inverse of 9. So we're looking for the inverse of 9. So you come here, the inverse of 9 is this value. This is like the value for the inverse. So I guess the thing.
But now it's mod 23.
5 mod 23.
Just write mod
23. So what you're saying is like the inverse of 9, to understand it, the 9 mod, like inverse of like 9 mod 23, the inverse is this. So if you, yeah, so if you multiply this by the other value, you get.
It's supposed to be 1.
Okay.
But now change this one to positive. It's negative 8, is it?
I don't know. Where's the rabbit in? Terrible.
Just make it negative.
Negative, yes. Like,
yeah. Just change it to positive.
So a question, like, so if you like the when you say like I'm finding like the inverse of like 9 more 23, the one we wrote at the beginning. So if you like the value of that one, and if you multiply the value, this value you get give you one. So this one is like the inverse multiplicative of the other value. So that's the equation now. Okay.
But now normally you make it write the positive number. So it's positive number, just add 23 to that, negative 5. Get it 3. So 18 now is a positive 1.4.
Okay, I'll just get it.
Yeah.
I'll ask that one.
Yeah, that's correct.
Okay, thank you.
So that's correct. The inverse of what you are looking for was the inverse of 9 would be this negative 5. And now you make it positive. It becomes 18. Becomes 1823. So what we mean, therefore, is that if you multiply these two numbers, 9 and 18, if you multiply 9 and 18 mod 23, supposed to get 1. You get 1? Just multiply 9 times 18 mod 23. Does it give you 1? Just do it with your calculator. Gives you 1. Yes. So I had said that even 5 was correct, but we just wanted a positive number. Is that okay? But 5 was correct. In fact, it's 5 that has given us this 18. Negative 5 was correct, but you make it positive. Yes. Yes, next person. Come and give us the inverse of 7 mod 20. The inverse of 7 mod 20. The inverse of 7 mod 20.
So first we find the Euclideans. So it will be 20. Then we see how many times 7 goes into 20. So that's 2 times. 2 into 7, and then the remainder will be 6. Then we get 7. How many times 6 goes into 7? That's 1 time. So it will be plus 1. Then we get the next number is 6. We see that here, I think the Euclidean already found that one is the GCD, and so we've gotten it. So we can just use this and reverse it. So like make 1 the subject. So is equals to 7 negative 1.6. Correct. And then like we start to substitute the numbers. Here 7, here it will be 7, then 1, 6 here. It should be 20. Is it 20? Are we substituting with this?
This is the 6. Huh?
Yeah.
So you write the equivalent of 6.
Yeah, 20 minus 2.7. Yeah. 20 minus 2.7. Then here we continue that. Here it will be 1.20 and multiply. Then here it will be, I think, the same 2.7. Also, it will be positive. Yeah. And then after that, we can group the like terms. 7. We can group these two, so we get negative. Is it 3? Oh, this is 7. How do we group these two terms? 1 point.
Just put 1 here. 1 times 7.
1 times 7.
So this is like 1 times 7, and this is 2 times 7.
All these are the like terms, so it will be 3.7. See,
just rewrite this as 1.7. Then that is
it's 1.7.
just the same thing.
Yeah.
So now the terms.
So it will be 3.7. 7 plus minus 1. And then based on what we had here, we can rewrite this into. You're supposed to substitute the 1.20 from here. If I'm correct.
We've already substituted all of them. Is that okay?
Yeah.
You began by substituting. The first one you substituted, you wrote the first one as the subject. Is that okay?
Yeah.
Which is 7 minus 1.6. Then you substituted that is 6. So you have nothing else to substitute. So what follows, you have to write the inverse of 7 from the equation that you have.
Also, the inverse of 7 from this equation.
Yes, that is the inverse of 7 from there. The inverse of 7 is supposed to be that element, which 1 multiplied by 7 gives you 1. And you have it, that 7 times a number here you can see has given you 1. You began with 1 is equal to 1 is equal to, that means this number times that gives you 1, and this number times that gives you 1. So if you look at that equation, you're supposed to now see what element is multiplied by 7.
It will be 3. 3 and then
so 3 is the inverse of 7 from that equation.
Yeah.
Okay. Because it's 3 that when multiplied by 7, you got 1. So 3 then is the inverse of 7.
Okay.
Yes, mod what?
Mod 20 from here.
Yeah, because 3 times 7 is 1, is that okay? From yes, 1. That is correct. We just look at those steps. Next. $795. 795. First of all, you have to find out whether it has inverse or not. If there is a like term, then it means it has inverse. And then a common term, 795. Is that common term between the numbers I've written so that she can proceed? Huh? Are there like terms? Can 3 divide those numbers? 3, this is 7. 7 plus 8 Up to 15, 3 can divide the first number here. Is that okay?
Yeah.
About this one.
95.
16. 3 can divide those numbers. Huh? Okay, let's change this to 975. Let's divide that. I'm trying to think of a number that I want them to be relatively prime. Just a minute. Let me just see. Let's change that. 37.
795.
Change it to just make it 743. Using 743, just make it 743. I think we are going to okay, so let's just find I said there were 7 what?
743. So since they
Click here and then you scroll click on the pen. The cursor. There is just share it. This is the one I was seeing. This is for this. This is all the one. It's coming back. Yeah, that's this. Was what? 3?
753. Okay, so now we'll use the Euclid's algorithm and the GCD. So 743. That's how many times?
Let's assist divide. Looks like 3, like 1.
Okay.
1 or 2. 1. And the remainder is 359.
And then 350. The eraser. So 3 is 1 times.
That was 359, eh?
Yeah.
The remainder 25.
And then 9. Um,
14.
the remainder. And then 14. This is 1 times 9. Yeah. One times 5 plus 4. Okay, so after that, we use the extended Euclidean algorithm. So we make one the subject.
How is supposed to use the multiplicative for the remainder? Because what is 3 is 1.339 plus 25. And that is 25.
Yeah, what?
55.
Yeah, that's 25. Yes, 25.
29.
Between 59 and 14.
Oh, you're referring to this line, huh?
Yes.
She said 25 goes there 14 times.
Yeah.
And the man is-
25 or the other way.
That's multiplication.
So when you're writing, yeah, you can write whichever can come. Yeah. You can write even the portion this side. You is talking about this 14. You're talking about this 14, huh? You want it written here and the 25 here. Yeah, they can be reversed. So long as you understand what you are writing.
Zero. Yeah. Ya kwanza.
That's easiest way to do this.
That's it? Like 5 times 1, right? Then 5 times 1. So that's
5 outside,
yeah,
then 2.
yeah, 2. Because they're 2 now. Yeah. 9 and 8. Nataka nakuja. So nataka the 10 now. So Anka 5 in other form, so 14 minus 1.9 times 2 plus 9 times 1. So inakuwa now we rewrite 9. 14 times 2 minus 9 inakuwa 359 minus 25 times 14. Yeah, 25. 14 times 3 ni?
That's 25.
14
Then
times
14
3
times
ni?
3, which is 42. That one is 25, isn't it?
Yeah, 25. And Vicky. And then, yeah, so I forgot.
3 times 14 is 42.
Because we're rewriting the 25 for the 14.
It's supposed to be 3 times 7, 25.
Yeah.
It's supposed to be 3 times 25, which is 75.
Well, that's 14 times 77 minus 359. And 359. I forgot 25. Yeah. Yeah.
Replace not 5, replace 9, so to replace 25. Huh?
Yeah.
So in upper here.
I did put myself used 14 instead of 25. Because it's 25. Yeah. Yeah.
Yeah, you see when you write, you're supposed to follow to written.
Yeah, order.
The order is supposed to know the order so that you follow it. But whichever way you can write, follow it. Like now, what she was writing, whatever was on this side was the number of times it was going there. So, and then this is the divisors.
Tuende tu tena. So 25 equals to 9 times 3. Eighteen. There you go. Hapa mbele ni
Sometimes hata kama ungezipanga vizuri, you look at
the one that
the
comes on
the
the
one
side.
that comes last, so that
Yeah.
we do
Yeah. Nikitumia unajua umezoea the brackets, so nikitumia the dot inani confuse.
That's what I'm saying. What is coming next? When I what is coming next?
So 1 equals to 7 minus.
So what is coming next is 3.
Yeah.
What coming next is 3. 2.
It's 2, yeah.
Oh. So what is coming next?
3. Minus 9 times 3. So next is 7. So this is 7 plus 4 times minus 9 times 3. 25 minus 9 twice times 4 minus 9. Yeah, 9. It's 359 minus 29.
It's 20.
25. Yeah. This one here, 14. 14. 25.
Is in the one last year.
Yeah. Five is 34 minus that. Mm, 359. Yeah, 359.
Which one is this? We've already calculated them. We've already calculated them.
Yeah,
Which one? Which one?
this one and this one.
Which ones are left terms?
This is 359.
Oh, it's not only 59.
Yeah. So my next is 359. This
And
is
bracket.
this one. A 1.
One. Huh?
Yeah.
Okay.
369.
This one's adding.
This one and this one.
This 7, 2, 3. The 7 is in the last. Then it will be
minus 753, which is 3 to 4 plus 753 times -169. So we're finding the inverse of 384. So that's 327.
She says it was what? Let's just multiply and see what I say was. But if it's not, then we'll check where the mistake was. What is 3 to 4? 3 to 4
And
times
327.
3.7 to get to 105,000 and something. What is the mod? 743 minus 69. Yeah, this is the universe. Yeah. That's how we find the inverse for that. So I think we can have a short break and then we'll continue after that. Just a short break. Wakati umefika pale. Yes.
Is that so? Let's find the GCD in the Euclid. So how many times does 13 go into 730? 56. Remainder 2. 13. How many times does 2 go into 13? 6 times. The remainder of 1. Eliza. Put out. It's okay. Then now we do the extended Euclid. So making 1 the subject,
becomes 13 minus 2 multiplied by 6. 2 is our previous remainder, so making 2 the subject, that is 730, sorry, 730 minus 13 multiplied by 56 times 6. So that becomes 1 is the same as 13 minus 730. Oh. So it becomes 1 is the same as 13 minus 730 times 6 plus 13, 56 by 6 is what? 56 by 6, 336. Collect like terms together, that is, this is 1, eh? So that is 13 into 337 minus, so when is this? So our question was 13, find the inverse of 13 mod 730. So this is what we're looking for. This is the inverse we're looking for. 13 mod 730. X is 337.
Let's confirm if that is the inverse. So we multiply the two numbers divided by what?
730.
So this is 337 times 13 gives us 4,381 divided by 730. Those are 6 times, and the remainder is 1.
Yeah.
That is the inverse. That's correct. Next. Okay. So.
Okay, so we start with the, so first to just ask, is it possible, does it have an inverse? 20 and 87. CD1. Yeah. Right. So Euclid's algo, we'll start with that. How many times does 20 go into 87? 4 times. The remainder is 7, right? Okay, how many times does 7 go into 20? Have 2 times. The remainder is 6. How many times does 6 go into 7? Have 1 time. The remainder is 1. This is GCD. So we use extended Euclids to find that. Right? So make 1 the subject. We have 7 minus 6 multiplied by 1. Okay, then we have our 6, so we place that. So we have 7. What's our 6? Make 6 the subject here. It's 20 minus 7 multiplied by 2. Then there was a 1 here. No, not wrong. Okay. So expand this to, this is 20, right? Then minus becomes a plus, or because the 1 is negative. Okay. Yeah, there's a negative. Yeah, there's a negative. Okay, okay. Right. Then this is 2, yeah. Good. So we have our 7. So let's collect like terms first. So this, of course, is multiplying 1. So you have, does that come to 3? Yeah. Then minus 20. Good. So we have 7. 7. Okay. So making make 7 the subject. So 87 minus 20. Okay. So 87 minus 20 by 4. All this multiplied by 3. Then minus 20. Right? Okay. So let's open this. So it's 7 by 3. Is that so? Then I have 20. 20, so this comes to 12. 20 to 12. Then minus 20. So like terms, 87 to 3. Like terms here. 22 to 13. All right. So let's look at our equation. Let's look at our number. So it's 20 and 87. We have that here. So what number multiplied by 20 gives you 1, right? Okay. So would it then be 13? Negative 13, right? And then we need to make that positive. So that would be mod 87. So it's 87. So 87 minus 13, right? Yeah, 74. 74. Yeah.
Let's just confirm. 74 times 13.
74 times 13.
Was it 13? What was 20? Was the okay? It's supposed to be
No, it was
the inverse of what?
of negative 13. Inverse of
The inverse of 20.
yes,
Yes.
inverse of 20.
And we found to be 70.
74.
Mod
187.
87. So it was 18 times. What are you giving?
Are we on the right path? Jeanette?
It was mod what?
87.
87.
Yes.
Mod 87.
So mod
Because there
87.
are 17 times. Okay, the inverse of 20 we found to be
It was negative 13. Then mod 87.
supposed to be 74.
Yeah, 74.
We found 70.
74.
74 times 20. Huh?
1480.
Mod
87.
87. Was there 17 times? What's the remainder? That's okay. What is the inverse?
Thank you. Thank you.
Amejua yeye amesema amemisi mingi, sasa nataka kumwongeza ingine. Yeye amemisi mingi. Welcome.
Seven mod. So we're supposed to find the divisors if like the GCD of 7 and 41. So I don't think like the GCD is 1. We're just looking at it because 7 doesn't go to 41. So there's a formula for, so we've got like, so this GCD is 1. GCD 1. So you try and divide, go to, I don't know, you divide it now. So 41 comes to this end. So how many times does 7 go to 41? 5. So I'll do it like Alex has done it. So the one we're multiplying, put it into brackets. So 5 times. Yeah. Then the remainder is plus 6. Plus 6. So the next thing is now the pattern is like 7 comes here. Then 6 comes here. So it's like 6. Then you put it into bracket. So how many times does 6 go into like 7? So it's 1. So it's like 1. And the remainder is plus 1. So again, you do the exact same thing. So this one, some pattern goes like this. This one goes here is like 6. Then 1 comes here. Oh, we found 1. So like found it. So I think like this is the GCD. Found it. So so I think we found like what you wanted, I guess. So see, GCD is 1. So now we start replacing it. Oh, now we start replacing it. So as we found the GCD is 1, yeah. Now we go back doing the inverse now. You get. So you write the equation in the form of 1. So it's 1, which is 7 minus 1.6 over 1 times 6. By 1 point, I mean times. So you replace this one like the equation. Now we replace it. Replace the 7 and we replace the 1. We replace this 6 now, I guess. So because we've done this, so replace the 6. So 6 now the equation becomes 6 is equals to 41 minus 5 times 7. I guess that's the thing. So this now the new equation. Now you do this, you replace this 6 here. So it becomes 1 is equals to 7 minus 1. Now this one is multiplication sign. So it's 41. I guess 41 minus 5 times 5 times 7. Yeah. Like that, then like that. So, yeah. So, this is the last page. So, okay. So, you do 1 is equals to 1 is equals to 7 minus 1 times 41 is 1 by 41. So here it becomes plus 1 times this one, positive 5 times 7. So 5.7. Now like terms, yeah, which is like the same as writing 1.7. So this one's 1.7 plus 6 times, oh, no, 1.7, it's 1 times 7 minus 1 point, like this is 1 times 41 plus 5 times 7. You get? So the equation says is 1 times 7 minus 1 times 41 plus 5 times 7. So you collect like terms, which is 1 plus 6, 1 plus 5, which becomes now 6. So it becomes 6 is equals to 6, or 6 times 7 minus, so minus this minus 1 times 41. And the equation looks for the inverse of 7, like this one. So I guess like the inverse, I guess is 6.
So that means 6 times 7 or the 41, that's correct. So 6 times 7 is 42. Now, so you see, the importance of finding the inverses is that, again, we can use them to solve equations. Is that okay? For instance, if I was to begin from this, what he has just done, if I was to be given any equation involving 7 and 41, I now know the inverse of 7. Is that okay? So for instance, let me just create some page. Create some page and share it. Yes, I'm going to create some blank pages. Yeah. Now, so let me share this. Now, from the previous example that he had just done, he had found the inverse of 7. He had found the inverse of 7 mod 41. And I was saying that the essence of finding the inverse is that so that we can solve any congruence equations involving those two numbers. For instance, if we are given 7x is congruent to, let me say even 3 mod 41, using the inverse of 7, we know that to make x the subject of the formula, that means find x. This one means find x. So to find x, you need to make x the subject of this formula. So if you have the inverse of 7, it means you multiply by 7 on both sides, the inverse of 7. You multiply by the inverse of 7 on both sides. So the inverse of 7, we had found that it is 6. So it will then mean multiply by 6 on both sides and multiply by 6 on both sides. And I know that this is a number and its inverse. So that will give us 1. So 1 times x gives us x, and this gives us 18 mod 41. So we have the value of x. So once you know the inverse, then it becomes very easy to find the value of the unknown. Is that okay? And that is why we look for that inverse. If you have it, you get the value of the unknown. Of course, we know you can do this question, in fact, without looking for the inverse and solve for it. But if you have the inverse, then you just multiply by the inverse on both sides. Is that okay? Now, let's do this. Find, Lynette, come and do this. Find the inverse of 13 mod 50 and use it to solve 13x is congruent to 4 mod 50. So begin by finding the inverse, and then you proceed to solve. So we have begun another round.
Yeah. So first we find the GCD using Euclid's algorithm. So 50 equals to 13. That times 3. Plus 3.
3 times 13.
That's 39, yeah.
About 3 times 4. 13 times. Yeah. Oh, it was 13, huh?
Yeah.
13 times 4.
Yeah. Okay, so now 13 equals to 11 times 1 plus 2. 11 is equals to 2 times 5 plus 1. And then now we use the extended Euclidean algorithm and make 1 the subject. That's 11 minus 2 times 5. 13 minus 11 times 1 times 5. Eleven times 6 minus 13 times 5. Then next we rewrite 11. So 13 times 3. 4 times 5. That's 23. Yeah. So we were trying to find the inverse of 13. So if we rewrite this, it will be, so the inverse is negative 23 mod 50, which is 27.
That's the inverse of what?
Of 13 mod 50, 27. Yeah, okay, so the inverse is 27. So now to solve for 13x is congruent to 4 mod 50. We'll multiply both sides by the inverse of 13. So it will be
It's okay. Let's multiply it now. That's 4 times. That is 4 exactly.
yeah, this 4. What else? 108. So yeah, I get 108. What times 4 times 27 is 108. Yeah, 150. Yeah.
150.
Okay. Oh yeah, 108 divided by 50. The remainder. Yeah. So it's 8 because it has to be less than 50.
Yes, that's correct. So the answer is 8. The answer is 8, and you can try and see if you were to come back and try 8 in the question that were given. 13 times 8, and you did mod 50, you get 4. That means x is 8. Next. Next.
We start by finding the GCD, so the Euclids. Given 19, how many times the 7 go? Twice. The remainder of 5. Given 7, how many times does 5 go once with a remainder of 2? Given 5, how many times does 2 go twice with a remainder of 1? Then we now start reversing the extended, making 1 the subject. That becomes 5 minus 2. Making 2 the subject, so it becomes 5 minus 7 minus 5 multiplied by 2. That becomes 5 minus 7 to 2 plus 5 to 2. Let terms together, 5 multiplied by 3 minus 7 into 2. Making 5 the subject becomes 19 minus 7 into 2 times 3 minus 7 into 2. Then that becomes 19 multiplied by 3 minus 7 multiplied by 6. Yeah. By 6. Okay. That becomes 19 multiplied by 3 minus 7 multiplied by 6 minus 7 multiplied by 2. Collecting like terms together, that is 19 yes. So we are finding the inverse of 7 mod 19, which is negative 8 mod 19, which is the same as 11. Okay, you okay till then?
Inverse is 11,
Yeah. So we're supposed to use this to solve for x
minus 2.
plus 2 plus 2 plus 2 is congruent to 9
minus 3x
minus 3x
would
would 19. It's okay. So we first collect like terms together. Yeah, this is 19. So we collect like terms together. So we bring this to this side, this to this side. So this is 4x plus 3x is congruent to 9 minus 2 with 19. So it becomes 7x is congruent to 7 with 19. We found the inverse of 7 to be 11. So that is 7 times 11 is the same as 11 times 7 with 19. So this is 1. So that is x is the same as 77 with 19. We reduce.
Wait a second, and these are inverses of each other.
Oh, so that's 1.
But we
still get 1.
By
4 by 4. Oh yeah. Yeah, still be 1. So x is 1. So it will be 1 with 19. Okay, thanks.
Next. Yes, next.
Okay, so we start by finding the GCD of 75. It goes into 13 goes there. Oh, it's 11, so 211. Right. 11 goes into 7, 5, 6 times. 6 times 9. Then we take that 9, 11, and make it the primary, and then 9 goes into 11 one time. And then 2. And we start 2 goes into 4 times, and then the remainder is 1. And then we get the GCD. So if we make 1 to be the we get from here. So we are making 1 to be the prime. So it will be 9, 9, then negative 2. Yes, and then so from here, now we start to substitute these values. So hapa from hapa inaendaje? Nisaidia hapa. So 9 inabaki. 9 inabaki, and then we substitute 2 with
Equivalence. 2 is here. To the subject of the formula. When you make to the subject of the formula, you have 11 minus that. Let's page.
And then this the 4. See, so the 4 comes here. Or this one. Yeah. Yeah, so we group them, so itakuwa 11 positive, and then this will be 9 times 8. If you multiply these two, hapa itakuwa 4. iandike mwisho. Okay, so hapa kama and then from there, like terms. So if we collect the like terms in our -2, 9, -2, 4. Okay. Like that.
Which one is that?
The 11 and
which one is the like terms? 9 and 9, huh? 9 and 9.
9 and 9. So
Google to the job. So we have to check so for example, if you're doing the second one now, you are substituting to the equation. Yeah.
That is done.
So after like if you find like terms on the second, like we've done like the 2 and you find like terms, you also collect like terms before you go to the other one. That's the process.
So you said like the like terms are 9 and 9.
You have 9 times 1, 9 times 4.
But when I was asking when I multiply this 9 and the 4, see, you correct that?
That's the result.
Okay. So hapa itakuwa iko sawa hii 9. And why don't we add these two? The 11 and the... Why don't we add?
That step is rewritten. This step you've rewritten it here.
Yeah, I'm asking how. Why don't we collect this? Me kwangu zinakaa like that.
Okay. The like terms will be, we're looking at the remainders. The remainders which are like terms.
Oh, so all the 9
remainders which are like terms. This 4 is not a remainder. 4 is not one of the remainders. The remainders are 1, 2, 9, and 7, 5. Yeah? 1, 2, 9. So those are the like terms of it. 4 is not one of them. So you get it, yeah?
Yeah. So if you group this 9 and 9,
yeah, the remainders which are like terms.
Is it supposed to be 18? And then
is it okay? What is
it supposed when I group these two like terms?
Is now grouping the like terms. It's 1 times 9 plus 9 times 4. So just factorize 9.
Factorize 9.
Yes. Yes. That's right. What I'm saying. First, and then we see. Just erase that. It is 9 times 1 plus 9 times 4 minus 11 times 4. So how do you get 18?
Okay, so for my case, I added the 2 9s, but if I go evil.
This is a multiplication. There's a plus sign. The only way you can do is to factor 9 outside the bracket. Factor 9 out. Yes. 9 out. 9 will go. 9 will go. The first part will go there once. go here 4 times. Inside the bracket. So 9 outside the bracket. 9. And then inside, and goes there once, and then it goes there 4 times.
It goes 4 times.
So close the bracket.
Yeah.
Yes, and then
Minus the 11
4 times.
times. Okay.
So that is 9 times 5.
9 times 5 because
What is inside the bracket? What is it? What is inside that bracket?
yeah, it's 9 times 9 and 5. Okay. And then
now
after
replace the next remainder. Replace the next remainder. How many remainders are we replaced so far? It began by making 1 the subject of the formula.
and
Then
then
we replaced the 2.
we are at 9.
Now you replace 9.
Yeah, so
What's the equivalent of 9?
75.
Yes.
So here it's supposed to be the 75 should
75 minus
minus 11 and 6. 11 minus 11 and 6.
rotation in the bracket. Because there's a 5 out. There's a 5 here, you see? 9 is multiplied by 5. So the equivalent of 9 should be multiplied by 5.
So there should be a 5 outside.
Exactly.
Yeah, and then this is a 4. Okay, and then should I
Let's open the bracket.
should I open the
Using
bracket
what is outside the bracket.
and then multiply 5 times 75?
Just multiply, just write.
How many?
Just write 9 times. No, 5 times. Just write what you said. That you
75. And this 5. Now when I'm multiplying the 5 with this 11, should
there's
be
something inside the bracket, then multiply 5 inside the bracket.
so inakuwa 11 into 5 into that 5. Like this. How can I open this bracket here? 5 with
Okay,
11?
everything was correct. Now correct like that again.
So if I collect this, should be 5, 25. And the 2 11s should be 11, and then the bracket 4. And then from above, thank you.
Okay. Okay. What is the inverse of 11 from that step? From where he has reached was the inverse of 11? Negative 34. Negative 34 is the inverse of 11. We are doing it mod what? Let's go back to the question. Negative 34 mod 75. It looks like 41. Is that okay? Huh? 41. Huh? Let's find out whether it's true that 41 times 11, 41 times 11 mod 75. What's the remainder? One is the remainder. What is the remainder? 1 is the remainder, which means it's true that that is the universe. But 1 is the universe.
So like tukifika hapa,
Yes,
how do we compare?
mahali tumefika hapo. How did we proceed from there?
How do we compare?
Yes, when you reach here, this is the same as 5. This is 7.5, eh? Plus this minus here. So this means that the universe of 11 is that minus 34 mod 75. So when you add this and this, you get 41. 34 negative 34 is the same as 71. Is congruent to 71. 34 negative 34 is congruent to 41. So that is the universe, therefore, is 41. Yes. We just found the universe. We have to solve the question that follows. What was the question? 11x
11
to 13.
to 13.
11x is equal to 13 mod 75.
Using our solution, we should replace this 11 with the 41.
Multiply by 41.
Yeah.
That is 11x.
11x. Na hii side ingine au 13, sorry, times 41 na iweke yote ama
Yes.
times 41. Okay.
But you multiply the number before the mod.
The number before the mod. Okay. So itakuwa 4. So we are not multiplying 11 and the 41. Oh, it's okay. And then 13 times 41. 53. Yeah. 8 nini? So 33. Oh, itakuwa 8. Oh. So the answer is 8.
So 8 is the answer. Next. Umesema umemiss mengi. Umemiss. No. Once you reach the universe, you are done. So, once you reach the universe, you are done.
Okay. So we begin our equation. So it's your number of 11 mod 94. So does 11 go to 94? I don't think so. So the GCD is basically 1 since 11. 11 is a prime number. So we come and do the equation now. So comes now, you do the Euclid. So after you do the Euclid, which is 94, which is equals to now the 11, which is 11 like this. So how many times does 11 go to 94? I guess 8 times. The remainder remains 6 plus 6. Then let's continue. So this one goes here. This one goes to the other one. So it becomes 11 this side. Because to this one becomes here 6. So it goes here once. So it goes here once plus 5, I guess. So this one goes here, this one goes there. This one comes 6, then becomes here 5. So 5 little brackets. 5 goes there once, and the remainder is 1 plus 1. I get it. So that now I'll make 1 the GCD, which is 1. From the GCD of the equation was 1. So the equation in form of 1. 1 is equals to 6 minus 1 times 5. Let's just write it like this. Yeah. So we've done this one. So we are done this one. So let's go to this one. So you try and place 5 into the equation. So how do you write this second equation? So this one is equation number 1, equation number 2, equation number 3. So we replace equation like 5 with the second equation. So the second equation was 11 minus 1 times 6. 11 is equals to 1 times 6 plus 5. So if you replace 5, it becomes 11 minus 1 times 6. So this is the 5 now. So this value here, you come to replace this 5 here, this one, which is here. So this is the value of 5, this thing here. This is the value of 5. So it becomes 1 equals to 6 minus 1. Now into brackets. Now this is the new 5. So it becomes 11 minus 1 times 6, I guess. Is it right? Am I supposed to press it? Oh, okay. So 1 times 6, then you close it. So the equation becomes 6 minus negative 1 times 11 becomes negative 11, or 1 times 11. Then minus, this one negative 1, so it becomes plus. So it becomes 6 times this, so it becomes 6 times 6. I guess. Oh, it's 1. It's 1. Also, it's 1. Oh. So how do you bring that trouble thing? Okay. So it makes sense. So and here it becomes 1. So now you collect lifetimes, which are these ones, which becomes now 1.6 minus 1.11 by point, I mean times, plus 1 times 6. So collect lifetimes, this one becomes 2 times 6 minus 1 times 11. I guess I'm correct up to there. So yeah, now go to like, we now replace like now replace 6 now in this equation. This now we go to change this equation here. So the original equation was 94 is equals to 11 into bracket 8 plus 6. So 6 is equals to 94 minus 11 times 8. Then like you replace now this is the new 6 now. No, the other equation. So this one is just the same as this 6 that was here. So you replace it in this now, this equation that we found here. Okay, so the equation was 2 times 6. So 2 times 6 minus 1 point, oh, let me just write. Oh, no. Let me wrap this one. Let's write the proper equation now. Yeah, what will be down though? Anyway, so this one's what? This is 1 times 11. So it becomes 2. So it becomes like this one is equals to 1, I guess. I'm not so sure this one is equals to 1. Yeah. Don't bring it there right now. Actually, draw. So it becomes 6. So it becomes 6, 2. This one is equals to 1. So this one is basically 1 here. So here's 1, this side 1. So this equation is also 1. 1 is equals to this one. So right, like replace this 6 now. So it becomes the equation is 1 is equals to 2. Like now we replace the 6 that we got, I guess, which is what they write it. It's here. So it's 1.2. So it's equals to brackets 94 minus 11 times 8. Yeah. Then this is the equation. Minus 1 multiplied by 11. Yeah. It makes sense. So now you do the equation now. So it becomes 2 times 94 minus 2 times 11. So itakuwa 22 by 8. Itakuwa 22 by 8. 22 by Am I looking for 11? Like so we leave 11 alone. 2 na 8. So okay. So we are trying to find the mod for 11. So basically, I think we don't change this value. So it becomes, okay, let's do it. 2 times 94. Then we can just write like this. 2 by 11 by 8 minus 1.11. Makes sense. It's still the same mathematics. Then now we collect like terms. So 2 by 8 is 16, as you were saying. So it becomes 1. This is equals to 2 by 94 minus, which is 16 by 11 minus 1 by 11. That one makes sense. So after that, now we collect like terms, which is 11s. So negative 16 minus 1 is equal to negative 17. So it becomes 1 is equals to 2 times 94. 2 times 94, I guess it's minus because it equals 17 minus 11. Then like we're looking for the inverse of 11. So the inverse of 11 is this value here. So it's 17. 17. Sasa kuanzia hapo it's negative 17. Oh, okay. So let me do that. So it becomes negative 17. Na sasa hapo hivi ndio mtanisaidia kidogo. Kwa sasa go back to the equation now. The inverse. What gives you, what do you multiply by 11 to give you 1? Okay. Find the inverse. We found like the inverse of 11 over 94. Now solve it. Like we found the inverse is so it equal like negative 17 mod 94 like this. Now I want a positive number. So we will like find the additive whatever inverse. 94 plus negative 17. So it gives you 94 minus 77. So 77. Yeah.
Okay. Inverse of what? Mod 94. There are 9 times. It's true. What is the inverse?
So 11a. So 11a is equals to 13 by 94. See 94. See maybe I understand. So if you multiply this one, you multiply by 77. See 77 times 11a. See there becomes 13 mod. Why do I keep writing like mod like that? I guess like 77 times 11a. So the answer like this side must have like an unknown value again. So here it remains 1. So it's like 1. The answer is 1. So here the one like you multiply by like the 77 now. You get it. So it becomes 77 times 13. This was a. Yes, this was a. 1001 mod. Huh? It's 94. Okay. So it's supposed to be 13 mod 94. So the answer is 61. Okay.
61 0.
That's all. After.
One. One to go. But my page is gone. That was the last page again. That was the last page. I think we can stop there. We have done enough exercise, finding the inverse and then solving those. Yes, and this thing is moving up. I press somewhere. Can move up to where? What's the limit?
I think up to usually for guys who like to stand past the time. So nilikuwa na swali na the last one.
Yes.
As we get to 77 multiplied, are you multiplying it by 11a or by 7? By 77.
The inverse, eh?
Yeah.
You multiply on the left side of the equation. This was the left side of the equation, and then the right side of the equation. You multiply it here, and then you multiply it here. Yes, yes.
Okay.
Then this other one, you got 1001, which you then reduce mod 94 to give you 61. You multiply on both sides. Yes, so let's stop there. Unless there's another question.